Hey guys, want to talk a little bit about scatter plots and lines of best fit and what they mean and how they can help us predict stuff. Predicting stuff is cool. You can find out stuff about the world that other people don't know, and maybe use it to your advantage. I don't know. Anyway, using the graph only about how much would you expect an 18-year-old to weigh? I'd probably expect them to weigh about, let's see here. 18-year-old, I'd probably think, okay, probably about, I don't know, about there somewhere, 180 to 190. That was just my best guess. There's no correct answer or whatever, but it looks like about somewhere between, yeah, 180 and 190. 4-year-old, yeah, probably about 40 pounds. That looks pretty good. If a person weighed 80 pounds, how old we expect them to be? Now you gotta work backwards. You gotta work from the Y's. So 80 pounds, that'd probably be about 8, around there, because this goes down, sorry, to the 8. If a person weighed 120, same thing. We just look up here. About 12 years old. That makes some sense. The line of best fit, so they're giving us a line of best fit here. This would be the slope of that line, and this would be the y-intercept of that line. The way you find a line of best fit is you draw a line as best you can through your points, and then you find the slope just by picking 2 points and just counting the rise over the run, and then you find out where it crosses the y-axis, and then that would be your y-intercept there. And then all you do is plug those into y equals mx plus b. Okay, let's see here. Hold on one second. Now they ask us to find the line of best fit for the scatter plot. Or actually, they're giving us the line of best fit. That's right here. Now they're asking us to find all this stuff using this equation. So we can't use the graph anymore. Let's say we didn't even have a graph, and there's probably going to be something like that on your test, where you have to use the equation. You can't use the graph. The equation is going to be somewhat more accurate generally anyway. It'll give us an exact number. If they say how much we would expect an 18-year-old to weigh, well, since x is our age in years, and if we look back up here, we can see, yeah, x was the age in years. So if I want to find out how much I would expect an 18-year-old to weigh, I just plug in 18 for our x, because they're telling me he's 18 years old. If I work all this out math-wise, it's a little bit tough. There's fractions and stuff, but it ends up being 185.5 pounds. So an 18-year-old we could expect to be about 185.5 pounds. Pretty close to our estimate here, but a little bit more spot on. We don't have to guess. This looks very similar. A 4-year-old, well, 4 is the age in years is x, so I'm going to plug in 4 because he's 4 years old. I'm going to plug that in for x. Work this out, and then subtract 7 over 2. I would get 77 over 2, which equals 38.5 pounds. Again, pretty close to what we have there, but a little more spot on. Using the line of best fit here, whoa, how old do you expect a person to be if they weighed 80 pounds? This is like reverse, right? Because if they tell us he's 80 pounds, they're giving us the y value. So basically, I plug that in for the y. So the x is the thing we're going to need to solve for. So I plug in 80 for y, because it's 80 pounds, and y is weight in pounds, equals 21 over 2x minus 7 over 2. It's just this line of best fit right here. If I work all this out, so I'm going to add 7 over 2 on both sides, and then multiply by the reciprocal of this. So I'd multiply each side by 2 over 21, and I'd end up with about 7.95 years old, which is really close to what we had here. But again, more accurate, it gives us a definite value. Line of best fit here, yeah, again, they're giving us the y thing, because the y is the weight in pounds. They're giving us the y variable. So I plug in 120 for y, and then I solve for x. So again, I would add 7 over 2 on each side, and then multiply by the reciprocal of 21 over 2, and I get about 10.74 years old. Interesting, so not quite as much as we would have expected. We guessed 12 there. It's actually closer to 10.74. This is important, guys. This will come up again and again. The rate of change of a line, the slope of a line is always what happens to y when x goes up by 1. So since x is age in years, when x goes up by 1, it means you're turning 1 year older. So the slope means that for every 1 year in age, so every 1 year you get older, you're going to gain about 11.5 pounds. Or sorry, it's 10.5 pounds. This is a misprint here. This is 10.5 pounds. So let's correct that. 10.5 pounds. Because 21 over 2 is 10.5, not 11.5. It's 10.5. What's the initial value of the line of best fit? Remember, the y-intercept is where we begin most of the time. And in this case, that's true. The y-intercept is where we would be when we're 0 years old. So if we're 0 years old, that's when we're born, right? So 0 years old, how much would we weigh? Well, according to this line of best fit, we would weigh negative 7 over 2 pounds, because that's our y-intercept. That's the same as negative 3.5. So if it means that a person would weigh negative 3.5 pounds when they're born. No, of course that doesn't make sense. You can't weigh negative pounds. The reason is, like, when we have a line of best fit, see how all our scatter plot points are kind of here? That means it's going to give us a pretty accurate prediction in this area, but down here, it's like kind of like all bets are off. We don't really have a lot of information there. We can take a guess, but we're not going to be able to make as good a guess as if we were in this range. So we could predict how much somebody 10 years old would weigh, 12 years old would weigh. What about someone 80 years old? Could we predict that? No, I mean, think about it. This would probably give us a number like close to like 800 pounds or even more. And that's totally not true. In reality, this line will not be linear. It won't be linear forever. It'll start to curve this way. Again, so we can't make any predictions kind of past this. And we know in real life, like, people stop gaining weight when they start getting to adult age. So this is linear in here, but it's probably not going to be linear forever. Hope this helps, guys. Make sure you're able to plug in, figure out what you plug in and what you solve for. So if they give you an age, you plug that in for x, since x is the age in years. If they give you a weight, you plug in that for y, because y is the weight in pounds. So knowing which your x variable and which your y variable are is important. I would highly recommend you kind of know the difference between what's it called, a manipulated variable and a response variable. That helps you figure out what would be on the x-axis and what would be on the y-axis. Hope this helps.